Hi everyone, in this video we're going to go through the fourth module of Datacamp's free Introduction to R course, Factors. So this module talks about factors. In particular, we're going to talk a little bit about what a factor is, why we would use it. Then the module goes in and talks a little bit about different factor levels and how we can set those within R. We're going to talk about using the summary function and being able to evaluate the types of factors that we have and what the frequency counts of those are. Then we're also going to talk a little bit about how we can compare the descriptive statistics of the factors within any particular variable. Lastly, we're going to make the distinction between nominal factors and ordinal factors and how we can set orders of our groupings within our variables. And then we're going to talk a little bit about how we can compare some of those. Okay, so here it really just outlines what a factor is. If we think about a factor and a variable, we can have different types of variables. So to make a comparison, we can have a continuous variable, so something that's measured in a linear continuous scale, something like weight, something like height, something like temperature. They're all on a linear measure. Another type of variable that we can have is a categorical variable. So something like male, female, or if we're using some sort of Likert type scale, strongly agree, to disagree, to strongly disagree. Or we can actually maybe even collapse something from a linear scale into a categorical variable. So if we think about temperature being measured on a linear scale in Fahrenheit as an example, we can categorize some of those from hot, mild to cold. So really what a factor is talking about the categorical type variable and how do we label the groupings within a particular variable that might be categorical in nature. So it wants us here to assign to a variable theory, and it wants us to assign vectors for categorical variables. So I'll just paste that in there and submit the answer. So in order to declare a vector as a factor vector, what we would do is we would use the factor function and we would pass through that factor function the particular vector of interest that are categorical in nature and that contain elements that are based upon categories. So in this particular instance here, we have a sex vector and it's concatenated with 5 individuals, and the individuals are labeled as male, female, female, male, and male. And so in order to convert the sex vector to a factor, we would create a new vector, and in this case we're going to call it factor sex vector, and we would call in the factor function and we would pass through that function the sex vector. So in order to do that, what we can do here is we can just call in the factor function and we'll pass through it the sex vector. Okay, and then it's telling us here that we want to print out factor sex vector. So we'll run the code. And it tells us here that within the factor sex vector that there are 5 different elements, male, female, female, male, male. And now you'll notice that we have the different levels defined, female and male. So we'll submit answer. So here in this particular section, it's distinguishing categorical variables as 2 different types. We have nominal and we have ordinal. In the previous example, male, female, the order doesn't matter. So a female is going to be equivalent to male in terms of defining a factor. However, in some instances, we may have orders. So we may have high, medium, low. Or as an example, we may have a Likert type scale where the respondents respond as either strongly agree, disagree, strongly disagree. In those particular instances, and using a rating scale, it might be labeled as 4, 3, 2, 1 from high to low with those labels. And so in that particular case, those categories are ordered because a strongly disagree would have a higher value than a strongly disagree. And so here they're using this example in terms of animals. The idea that with an animal, elephant, giraffe, donkey, or horse, in terms of defining it as a variable itself, are unordered. There's nothing greater of an elephant than a giraffe in terms of defining a factor. In the research, it might mean something, but in terms of defining a categorical variable, there's no distinguishment in terms of the order. All right, however, in temperature, we may have a linear scale and we may categorize them into high, medium, or low. In that particular instance, high is representative of a higher measure, low is representative of a lower measure. And so we have to make that distinguishment now between the nominal and the ordinal variables when we're labeling them as factors. So in this particular case, they just want us to take the code and run it and see what happens. So we'll notice here when it's labeling animals that it gives us the vector with the elements, elephant, giraffe, donkey, and horse, and then it just gives us the 4 different levels. And you notice that it just labels the levels here. However, when we're using an ordered factor, you notice here it does the same thing. It's going to label what elements are in the vector. However, in the levels now, it's telling us that low is less than medium is less than high. So whenever you get a new data set and you're checking your factors, that'll give it away as to whether or not the factor has been assigned as either a nominal factor or an ordinal factor. So we'll click Submit. So when you first get a data set, you will often notice that it contains factors with specific factor levels. However, sometimes you will want to change the names of these levels for clarity or other reasons. And R allows you to do this with the function levels. So earlier we had a function called factor, and using that function assigns a vector as a factor vector. So here we're going to use the levels function in order to better define the levels. So in this particular instance, after you get a data set and you're not exactly keen on how the levels have been defined, we can change those names by building a new vector. And in order to do that, we'd use the levels function. And in this particular example, they're showing us that we take the levels function and we pass through it the factor vector that we've already created, and we can concatenate the factor names, and then we're going to assign it as that new vector. So a good illustration is the raw data that is provided to you by a survey. Commonly, there might be 2 categories that have been assigned, M and F, representative of male and female. However, we'd rather have more information for our analysis. So essentially what we want to do is change the M to male and change the F to female. So if we come down to our instructions here, what we want to do is check out the code that builds a factor vector from survey vector, and we should use factor survey vector in the next instruction. So here we have the code to build the factor vector, and we've already been through this. So what we've done here is that we've built a new vector and we've called it survey vector, and we've concatenated the responses of the 5 individuals. So male, female, female, male, male. And we notice here in this particular instance, they're just labeled as M and F. So our next logical step is that we want to assign it as a factor vector. So in this next step, we've taken the survey vector and we've just named it factor underscore survey vector just for clarity purposes, gets, and then we've used the factor function and we've passed in the survey vector. And so if we run that code, what's happened here is that now it's been assigned as a factor variable. So now in this next step, what we want to do is we want to specify the levels as male and female. So what we're going to do is we're going to take the levels function and we're going to pass through that function the new vector that we've just created that's defined the old vector as a factor vector, and we want to use gets. So what we want to do now is we want to name male and female. We'll use the concatenate function, and then our first element will be female, our second element will be male. Okay, so we'll run this. So that's all been defined. And then lastly, what we're going to do is we're going to print out and see what happens. And so we'll notice here that the levels have now been assigned as female and male. Okay, so in this next step, now we're going to use the summary function in order to get a little bit more information in terms of what we're finding in our vector based upon the factors that we've been defined. So in this particular case, we want to know the frequency of the amount of males and the amount of females that we have in our vector. So in order to do this, we're just going to use the summary function and we can pass through the vector of interest, and that's going to now tell us a frequency of some of the information that we have in our vector based upon the factors. So in here we have already set up, we have our survey vector, we have the factor vector. So once again, what this is doing is taking the survey vector and defining it as a factor. And then here we've clarified the levels and we've labeled them as female and male. And then we've printed out the survey vector. So let's just run this code just to see what the factor survey vector looks like. So once again, we have 5 elements within our vector, male, female, female, male, male, and it's telling us that we have 2 different levels as factors, right? So we have a female and we have a male. So here now we want to generate a summary for the survey vector. So we'll use the summary function and we'll pass through the summary function the survey vector like it's asking us. Okay, so let's run this. And it's telling us here that we have 5 different elements. The class of the elements are characters and the mode is characters. So now let's take a look at and see a summary of the factor survey vector to see how that differs after we've assigned all of these factors. So once again, we'll use the summary function and we'll call in the factor survey vector. Let's run this. Okay, so we notice here now using the summary function, because we've assigned everything as a factor and we've labeled them, now it's giving us a frequency count. So it's telling us that we have 2 females and we have 3 males. Okay, so battle of the sexes. You might wonder what happens when you try to compare elements of a factor. In factor survey vector, you have a vector with two different levels, male and female, though we've already assigned it. But how does R value these relative to each other? So read the code in the editor and click submit to test if male is greater than female. So let's run this data and just see what we have first. Okay, so we'll notice here that we have the male, female, female, male, male. And what we want to do now is compare male against female in terms of comparison operators. So the best way to do that is we can create a variable named male, and we can take the factor survey vector that we're working with, and we can just pull out the first element, which is male, because male is represented as the first element. And then what they did here is that we want to do the same thing. We want to create another variable and label it female. And from that variable, we're going to pull out the second element of the factor survey vector, which is female. So that was the logic behind why they're doing that. And now the next question is we want to know what happens if we actually compare male against female in terms of levels. You'll see that it gives us an error, and it's telling us that the operator is not meaningful for factors. And that makes sense because in this particular case, they're nominal. So there's really no distinguishable difference in terms of labeling them as categories. So that now brings us to ordered factors. Since the male and female are unordered, R returns a warning message. However, this is not always the case in terms of it being meaningful in our research. So as an example, if we're interested in measuring speed, which is a linear measure, and we want to collapse some of that information, lose some information in order to clarify it as categorical variables such as fast, medium, and slow, those are now meaningful categories. So fast would have a greater value than slow. And so what it's asking us to do here is to build our own vector, and we're going to call it speed vector, and we have 5 entries within that vector. The first one is medium, second is slow, third is slow, fourth is medium, fifth is fast. In order to do this, we'll create a new vector and we'll name it speed vector, and then we'll concatenate 5 different elements. So the first one would be medium, separate it by comma. The next one is slow, separate it by comma. The third is slow. The fourth is medium. And the fifth element is fast. And it's telling us no need to specify the factors yet. So we'll just run the code, develop the new vector, and submit the answer. Okay, so our next step is that we want to convert this now to an ordinal factor. So there's a comparative difference now between fast, medium, and slow. So similarly to what we did before, we're going to create a new factor vector, and we have to define this as an ordered vector. So similarly with what we did before, we need to create a new vector and assign it as a factor vector. So in this case, we're going to call it factor underscore speed underscore vector. And then we're going to use the factor function. But in this particular case, because it's an ordered factor, there are 3 arguments that we need to pass through the function. The first is that we need to call in the particular vector that we're working on. So in this particular case, it would be speed vector. The second is that we want to assign whether or not it's ordered or unordered. So in this case, we are working with an ordered factor. So the second argument is ordered, and we'll set it to true. And then the third is that we want to define our levels in terms of their order. So we're going to call in the levels, and we're going to use a concatenation function, and we're going to use the levels within the concatenation function. So the way that this is going to look is we're going to use our factor function, and we're going to pass through 3 arguments. The first is going to be the vector that we're using, so speed vector. The second is that we're going to set the ordered to true. And the third is that we want to define our levels in terms of their order now. So we'll use levels equals, and we'll use the concatenate function. And we notice here that we have 3 levels, and we're going to order them from low to high. So the first one will be slow. The second one will be medium. Fast. Once again, separated by commas. R isn't necessarily looking at the spaces or the soft returns. In order to clean up our code, we can actually separate them the same way they've done here. It's not necessary. And the last thing is that we want to make sure that we always close out our function call. So we'll use another close parenthesis there. And now it wants us to print out the information for the factor speed vector, and it wants us to give us a summary. So we'll do all of that. We'll run the code. We'll notice here that when we printed out the factor speed vector, that in here we have 1 vector and there's 5 elements. So medium, slow, slow, medium, fast. It's telling us here that the levels, slow is less than medium is less than fast. So that's telling us that it's ordered in that particular order. And then the summary is telling us that we have 2 slow, 2 medium, and 1 fast in terms of the 5 elements. Okay, so in the instance where we were using the nominal factors, we tried to compare male versus female, and if you remember, we got an error message saying it didn't make any substantive sense to do that. So in this particular case, now we can compare the ordered factors. So as a playful example here, it says, having a bad day at work, data analyst number 2 enters your office and starts complaining that data analyst number 5 is slowing down the entire project. Since you know that data analyst number 2 has the reputation of being a smarty pants, you first decide to check if his statement is true. So once again, we're using empirical data now to see whether or not the argument is valid. The fact that the factor speed vector is now ordered enables us to compare different elements. In this particular case, we're analyzing the data analysts. So you can simply do this by using the well-known operators, so greater than or less than. And so the instructions here are telling us that we want to pull out the second analyst from the factor speed vector, and we want to store it as a new variable dA2. Next, we want to pull out the 5th element of the vector, and we want to label that as a new variable dA5. And now we want to compare whether or not dA2 is greater than dA5. So in order to do that, we're going to use the same type of processes that we went through before when we were comparing the males and females. Here we want the second element of the factor speed vector, and we'll use the brackets to call out a particular element, and we're labeling it now as a variable dA2. Now we want to have dA5, and we're going to use the same thing. We're going to take the vector and we're going to use the brackets to subset. So if we just run this, what we've done here is that we've just assigned the subsetted elements to a new variable. So the last point is that we want to compare now whether or not dA2 is greater than dA5. So we will pull out the variable dA2. We'll see if it's greater than dA5, and the response that we're going to get is going to be a Boolean. It's either going to be true or it's going to be false. So let's run all of the code once again, and the answer is false. dA2 is not greater than dA5. Okay, in the next video, we're going to be talking about data frames. I hope you enjoyed the video and found it helpful. If you did, make sure to give us a big thumbs up and like the video. If you haven't done so already, be sure to subscribe to our channel by clicking the link above, and make sure to check out some of our other videos. We'll see you again soon.